In this lesson, focus on the module WTW158, vector algebra, limits, derivatives, and integrals. And we proceed to solve a wide range of problems on these sections. And we focus on past exam questions as follows. Right, first we look at question 7. Apply the right-hand rule to find the following vector cross products. Right, so if we actually look at the fact that what would vector I cross vector J be, for instance? Okay, right, we shall obviously now stick to the right-hand rule. Now, there are a couple of things that you need to take actually into account here. That first, we can attempt to use our notions here. We can do this question like this. And the I corresponds to the first component, X, and the J corresponds to the second component. And with this mentioned, then we actually can be in a position to cross this column and this row, and we therefore are able to obtain 0 here minus J, right? So we can put the actual bars on top of each of these unit vectors. I, J, and K, our unit vectors, and we have plus K, right? And plus K means, therefore, you multiply this with that, and then you take the opposite, right? Getting exactly a 1 minus 0. And upon careful examination, we're able to see that this is 0. And right, so I want us to look at the J, please. So we multiply. Okay, let me write the J correctly. So the J, it's going to have also a 0 component attached to it, because if you look at the fact that you block this row in this column, you're going to have 1 by 0 getting a 0 minus 0, and that's a 0. And then we have a plus vector K, and we have this and that, which is actually then a 1 minus 0. Right, so as a consequence, then what then we're getting is we're getting the vector K. So in other words, I cross J becomes K. Right, so in other words, now let us look at the fact that these can be done in several ways, and therefore, if you take the vector cross product of a pair of vectors, you really can be in a position to compute the actual results there. So now, the actual right-hand rule of vector cross products, right? I want us to look at that. Okay, using the same notion. So in other words, right-hand rule for vector products. I want us to actually discuss this quite carefully and have a fair understanding of this, right? So this therefore becomes so key to our multiplications. In other words, I would say this is obviously normally what we do, but there is a way we use. So in other words, if you have I, J, K, for example, right? So in other words, if you then say I cross J, this becomes K in that circle. So you can put I here, you can put J there, and you can put K here. So if you then say I cross J, it gives you K, and you have this particular direction. So any vector cross product that is opposite to this, that goes against the direction of the arrows, would yield a negative result. Let's take a look at what this means actually. For example, so in other words, I cross J, just to mention that. So I cross J would yield a K. So without having to reason, I cross J becomes a K. Right, so where these are our unit vectors. So I cross J becomes vector K. Right, so using this particular notion, the diagram on the side, you can then say, for instance, vector K cross unit vector I. Now, let's look at K cross I. And therefore, we're able to see, therefore, that K cross I would give us vector J. And simultaneously, therefore, we can be in a position to analyze these very, very carefully. Right. And also, I mean, it's not the only way to do this particular question. If we then say K cross I is actually J, you can then look at the fact that you can perform a small division here and look at vector K cross I. Right. So that would mean you then would be in a position to then say that is going to be I, J, K. What is K? Right, so that would be 0, 0, 1 for the first one, 1, 0, 0 for the second vector, and this becomes actually K cross I. And therefore, this is actually exactly I. So if you multiply, if you block this column and this row, you'd have a 0 here, minus J, and you block this and that, you'd have a minus 1 plus K. You block this and that, therefore it becomes exactly 0. And if you multiply the negative gives us exactly a J. Okay, so we therefore can be in a position to then say, if you then have this exactly, you would have that particular result there. So we use that diagram, and also we can use this notion of the determinant to find the actual vector cross product, right? So any different view to this as a consequence. And also, there are a couple of different notions, obviously, that you can be in a position to reason this out. But once again, the diagram itself becomes very, very key in helping us interpret these with simplicity or with much ease. And obviously, when you can draw the right hand, all right, if you attempt to draw the right hand, you can be in a position to understand that. But now you can look at the fact that, for example, if you look at Z axis, this one being the Y and that being the X axis, right? So position your hand, okay? Right, you position your hand, and if this one here, for instance, is your right hand, and you have your fingers positioned in this manner. You have your finger, one of your fingers here, one of another finger positioned somewhere there, and therefore having this now, normally these being the fingers adjacent each other, right? So if this is your thumb, you have your finger that is next to your thumb finger, right? So if you have your thumb, and we have another finger there, you have another finger there that is next to your thumb. Away from the thumb, you would have two more fingers like this, two more fingers like that. Right, so this becomes one finger. This becomes another finger. You'll forgive me because, yeah, this is your right hand. I want us to just have a rough idea of that. So now if this is your right hand, and this one here, for instance, if you have, in general, if this is vector A, and this one here is vector B, then up there it's going to be vector A cross B, and this one is going to be up. So you have vector A in that direction, vector B in the direction of this finger, therefore A cross B will be in that direction there. Okay, so as a consequence, then this is what I understand that it's a nasty diagram, but yeah, it sort of gives an idea of what is happening. So use exactly that. So you can use the right hand here, and then say if you draw like this, and here is the hand. You have here a finger, and then here you have another finger, and then here these ones you have those fingers that you bend a little bit, right? Because you bend them, you have sort of the nails here, and so you have something like this. Okay, so these ones you have burnt these fingers, you bend them up, So that now if this one here is vector B, and this one here becomes exactly vector A, then up here you would have A cross B, like this. And now with this mentioned, let's use a different color, otherwise everything's just going to be red. So you can be able to draw sort of a diagram here. This one goes through that finger. This one goes through that finger. This one goes through that finger. So yeah, this is what you have then. So now you have two vectors A and B, and you take the cross product using what you call the right hand rule. Okay, so if you cross A and B, then you'd get a vector that is perpendicular to those. And this notion is sort of the notion that, yes, this is exactly what we're saying. So it is the right-hand rule. We're moving, please, to the next notion. It's the right-hand rule. So if you if you have A cross B, right, if you have vector A and vector B, and you cross A and B, what you get is a normal, it's a normal vector, sort of a vector that is perpendicular to the surface. Right, a vector that is perpendicular to the surface. Consequently, as a consequence, you can therefore be in a position to then say, as said already, you can have your Z, Y, and then X. So with this mentioned, if you put I here, you put J here, you put K here. And then right now, you then say, you have seen that if you have I cross J, we said that I cross J gives us K. Right, so in other words, if you have I cross J, we saw that I cross J becomes exactly a K there. Right, I cross J becomes K. So in other words, now you have this one, I, J, K, because K is the unit vector in the Z direction, J unit vector in the Y direction, and I unit vector in the X direction. So if you say I cross J, it actually therefore becomes a K. And so you have the directions like this. Much better illustration there. Much better illustration. So now if you then say I cross J, it gives K. And then you can say I cross, or rather J cross K would give, for instance, a different. Yeah, if you then say K, this one here, K cross I would give what? So note that this is going to be, is actually counterclockwise. It's counterclockwise. So right now, if you then say K cross I, what it produces, K cross I produces exactly the vector J there. Okay, something that you take note of. Let's move to the next point. Right, find S such that the vector A and vector B are orthogonal. Right, we remember, okay, there's some questions you shall do. Right, so if you have orthogonal vectors, we remember that the vector A and B would have dot product 0, 0s minus 1, dot minus 1 is 1. You dot them and you have a 0. Right, so, okay, if you dot this, 0 and that would give exactly 0. S and that would give us s squared, minus 1 and that would give us minus 1, which is 0. S squared equals 1, which means that if you have s squared, would mean that s is, okay, yeah, plus or minus here. So s is therefore going to be plus or minus 1. In the case, therefore, that the two vectors are orthogonal vectors, therefore, you have the dot product becomes 0. The end question, there at Lehang. No question. Okay, right. In the
No.
okay, that's fine. The absence of a question, we move forward. We move forward. Find the area of the parallelogram formed by vector A and B is two of the sides. Right, it's two of the sides. Right, so we continue. We continue. We continue. Right, so we continue. Right, now moving forward, we're able to get the following. We're able to get the following. Right, so, okay, we're going on. Let me give it just 1 minute to try this one, please, and then we shall discuss together.
Okay.
Yes, just try it in 1 minute. I want to see what you're gonna do, and then we shall discuss it together. Right, then we shall discuss it together. We shall discuss it together. We shall discuss it together. Right. Please let us know when you're done.
Okay.
All right, thanks. Right, please let us know when you're done.
Okay.
All right, thanks. Right, please let us know when you're done. Then we shall discuss it together. Just practice.
Okay.
All right, thanks.
I got root 6 units.
Okay, you got the square root of 6 units. That's awesome, 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 awesome. It's okay. Let us check together. So now you need to find the area of the parallelogram formed by this, and to find the area of the parallelogram formed by this, if there's something you need to do to find you need to find the area. Area of parallelogram. Right, parallelogram. What is the area? It's A cross B. A is 0, 1, minus 1. B is minus 1, 0. Right, and therefore this one is IJK. And then you have the fact therefore that you multiply these things. And if it is ijk, the A is 0, 1, minus 1. The next one, B, is minus 1, minus 1, 0. I. Right, so if you have vector I, you can put the bar on top. Right, you can put the bar on top. So in each case, therefore, you put this here. So now you multiply these, and then you get what? You get a minus 1, minus j, and then you get a minus 1 plus k. You get what here? You get exactly a 1. Right, so in the end, then, what actually is the meaning of all these here? So this would be minus vector I plus j plus unit vector k. Okay, this is actually what we're getting. I want to check if there's no error here and everything is okay, because the vector A is 1 minus 1 with 0 in the first component. The vector B is minus 1 minus 1 0, and if you block this and that, you'd have exactly a minus 1. And then now you would then have, okay, if you have here a minus 1, right, and you have the minus j in the middle column, and if you multiply these two, then you'd have plus and you have a minus there. Yes, Anela, how are you? Okay. Fine, thanks. Yes, welcome, Zanelli. Yeah, okay, yeah, that's excellent. What module is that? Just curious. Right, yeah, what module, yeah? What is the module code? Yeah, okay, can I give you a call after my class? I'm just in class now. All right, that's fine, yeah. Oh, I understand, yeah, but I'm just in class now. But after my class, I'll get back to you. Okay. Thanks, Anele. Goodbye. Right, so we have exactly this here. Okay, yeah, I'm sorry. I was just speaking to this student who is calling me, they're telling me that they want to register a module, and now they can't register. Okay, I'm getting that story, but yeah, I'm not an admin officer, so, but I can at least share some ideas on this. Right, so if you have the K, it would actually be 1. Okay, so, but the J, it's a minus. In the I, it's going to be exactly a minus. Is there any question you have here? So that the area, in particular, then to find the area, what we then do, because to find the area of the parallelogram, then you sort of get the length like this. Right, you sort of get the length of that. So in other words, so in principle, what we can do to write it nicely, we can first say, we first find A cross B. Okay, to make sure it's neat. After having found A cross B, then we then say the area. Right, then you find that you write that the area of the parallelogram equals A cross B, which is minus I j k, which is exactly the square root of minus 1 squared plus 1 squared plus 1 squared, which is the square root of 3 square units. Right. Any question on this? Any suggestion? Right, maybe you are seeing a mistake somewhere, but that's sort of exactly what needs to be done here. Please share your thoughts or any idea on this that is different. Okay.
I have no ideas to share.
Fine. I'm going to change the question. Find the area of the triangle. Okay, we have the word parallelogram. I'm changing the word because this says find the area of the parallelogram formed by A and B. Is two of the sides. Now, I'm going to change the question and say find the area of the triangle. Find the area of the triangle formed by A and B. What do you think of this one?
You want to take
Yeah.
the length you found for the parallelogram
Yes.
and multiply it by a half.
In other words, the area of the triangle. Right, so the area of the triangle is going to be 1/2 A cross B. And it's 1/2, and A cross B becomes the square root of 3. So this will be the answer, square units. Right, square units. I'm happy that you're able to follow. Okay, good. No question, obviously. And all is well. Correct. Let's move to the next point. Say whether each of the following is true or not and explain why. Okay, so we are going to work together. The reason why we work together is because, it's good to work together because together we stand, united we stand, divided we fall. Say whether each of the following is true or not and explain why. Right, so is it true? A cross B dot B, it's 0 for all vectors, A and B. Okay. So this one here, is it true or not? Okay, we're gonna discuss it together. But sometimes I know I do the most uncomfortable of things. Okay, let me first do it because I don't want you to feel uncomfortable. Okay, I want you to be comfortable. Right, first things first, we said that A cross B would be actually equal to a normal vector that is perpendicular to vector A and vector B, respectively. So because of this, then if you then say vector A cross vector B dot B, so in other words, we're having a situation where the vector product is a perpendicular vector with the B, perpendicular vector with the B. Okay, so a vector is perpendicular to B would have 0 dot product. Would have 0 dot product. Why? It would have 0 dot product. The reason for this is simply because orthogonal vectors have a 0 dot product. Okay, we can do this is exactly what one can say, but we can do an example. Okay, an example doesn't prove something in general. An example does not prove anything in general. Right, so, but now what then we're able to see here, and there are many ways to demonstrate, but yeah, an example, let's just do an example. Right, an example would be, for example, I and J dot J. Yeah, dot J. Now, what did you say about I cross J? What is I cross J? We said I cross J is going to be K. Right. And then if you dot it with the same vector, Right, you dot it with J. What would the result be? Let us check this. What is unit vector K? All right, so unit vector K is 0, 0, 1. Unit vector J is 0, 1, 0. 0, 0, 1. 0, 1, 0. And then now if you dot this 0 by 0, 0. 0 times 1, 0. 1 by 0, 0. And therefore the result is 0. So that obviously if you take, this is just an example, it's not a proof. And obviously you can always find a general way to prove this, but it is enough to then say if you cross A and B, you'd get a vector that is perpendicular to both A and B. And therefore now if you take the dot product of two perpendicular vectors of two orthogonal vectors, you have that results. You have exactly that result. Any question? Right. Okay. Right. I believe maybe it's a bit clearer. Okay, we have a different view. What do you think? Because I did not ask you first. I just, discussed it.
No question.
No question. 10.2. I need to hear your opinion. The reason why sometimes I need to hear opinions because I don't want you to sleep. So I know that sometimes you can fall asleep. I know you're a student who is committed, but students fall asleep sometimes. So now, in the end, then, yeah, so what do you think? 10.2, I hope you're able to see that. So we're having that vector u plus vector v cross vector v. Is it equal to this for all the vectors? True or false?
False.
False. Well done. Thank you. So this one is false. So if you have vector u plus vector v cross vector v, we're putting the question out there. If you have vector u plus vector v cross vector u, I mean, are these two things equal to each other or not? Well, I mean, we have already said it is false.
No.
Right, and the reason for this, it's because the left-hand side, so it's false, or you can then proceed to then say the answer to this, it's a no. Right, because the left-hand side and right-hand side have opposite signs. The left-hand side and right-hand side have what? Have opposite signs. Right, they actually have opposite signs, and therefore, as a consequence, then it is not true that you actually have that result there. Let's move on to the next point. Let's move on to the next point. Next. Okay, the other things that we're going to discuss, like the derivatives are coming and other things are coming. Okay, I want us to look at Frach-Ian. Right, Frach-Ian, or question 1. Let f be a function defined by this particular function, which is a piecewise function. Right. Give the value of values of k such that the function f is continuous. Let us look at these together. But yeah, the question becomes, what is exactly the most important thing here? And what then exactly is the what then exactly is the result to this particular question here as we move forward? Right, so if you look at these quite cautiously, what exactly do we have here as a consequence of this? Now, there are a couple of things that you need to take into account. F of 2 would be k2 squared minus 1, which is 4k minus 1. And the variance of k that the function is continuous. Okay, so if this is the value of the function, if the function is continuous, that means the limit as x tends to 2 from the left of f of x, this limit must be equal to the limit as x tends to 2 from the right of f of x. Now, from the left is when x is less than 2, which means you'd have the limit as x tends to 2 from the left of k squared x minus 1. And we have the limit as x tends to 2 from the right, bigger than 2, which is k. Okay, that's very interesting that they're playing a little trick here. So you need to look at the powers very, very carefully. Because, I mean, if you look at the part where x approaches 2 from the left, we have k squared. Here we have kx squared minus 1. From the left would be in the place of, right, so in the place of the x, you put the 2 is 2k squared minus 1. From the right, you put the 2, which is exactly 4k. Right, which is exactly 4k minus 1. Right, so we continue to sort of unravel this. So we have 2k squared minus 4k equals 0, which is k minus 2 equals 0, k equals 0, k equals 2. And therefore, these are the values of k. So obviously asking the question, so we'd have therefore that k is 0 or k is 2. Any question, any suggestion, any remark, anything to say here?
No.
All right, so let's move to the next point. Move to the next point. Right. Okay, I'm giving you these limits to try. And then please let us know when you're done.
Okay.
All right, thanks. And then we shall discuss it together. And then we shall discuss it together. Right, you let us know when you're done. Right, you let us know when you're done.
Okay.
All right, thanks. Right, we continue. We continue. Right, how far? Just checking on you.
Almost done.
All right, thank you. All right, excellent. Right, so we continue. We continue. We continue. Right, we continue. Right, right. How far? I'm just checking on you. You'll forgive me, please.
Almost done.
All right, thanks. Everything, I'll give you a chance and then we'll discuss it together. Continue. We continue. We continue. Right. Right. I'm
The
waiting.
limit does not exist.
Okay, that's fine. Because you're practicing. Never mind. I tease you all the time if I just give you something. The aim is just to tease you. Right, so we're taking the limit as x approaches infinity of 9 minus the absolute value of x, 9 minus x. We're taking the limits as x approaches infinity. Okay, as x approaches infinity, it means that we have x is greater or equal to 0, just greater than 0. So you have 9 minus that, and then we have 9 minus x, like so. Okay, so that is what we're able to see immediately. So with this, then, we're able to see that as x approaches infinity, this is the limit of, this is going to be exactly 1. So the limit of 1 is 1 because it's this divided by itself. right? Because as x approaches infinity, it means that, you see, the absolute value obviously has two parts. It is x if ever x is greater or equal to 0. It is minus x if ever x is negative. So as a consequence, what you're then getting is whenever x is greater or equal to 0, the absolute value becomes just x of x. It becomes just x, and therefore 9 minus x divided by 9 minus x is a 1. And the limit of the 1 is exactly a 1. And that is the answer. Right, so that is exactly what needs to happen, and that is the result. We move to the next question. I mean, you always know that these things are recorded, so you'd have a chance to look into this. Find the derivatives of the following. Do not simplify your answers. Vraag 4. Right, now 4.2 is actually f of x is equal to arctan of x squared plus 1. Okay, so we have a chance to discuss these inverse functions, but like the arctangent, the arcsine, the arccosine, the arccosecant, the arc, and so on. Right. So now to find the derivative of this is what I'm just going to do. Because I know it's not fair to you. It's not fair to you to just keep asking the questions. All right. I know the students are not comfortable. F primed. So the derivative would be f primed here. And the f primed would be the same area. So now, to find the derivative of arctan, so if y equals arctan of x, which is also like the tan inverse, yields dy dx, which is 1 divided by 1 plus x squared, or just x squared plus 1. X squared plus 1. Now this is going to be exactly that. And the derivative becomes exactly 2x. Derivative of the inside by the chain rule becomes 2x. Right, so we get exactly this. We get exactly that. That is the answer. I mean, you can write it in many ways, but you can write it as x squared plus 1 squared plus 1 like this. Okay, and this is the answer to the question. Any question, any remark, any input, any suggestion, any opinion?
No.
No, thank you. Go to the next point. Okay, find the derivatives of the following. f(1), which is x squared e to the power 10x. So this one, obviously being a product, we use what you call the product rule. Meaning, therefore, now if we have f primed of x, we have the derivative of x squared, which is actually 2x, 10x, x squared. The derivative of 10x is what? Is x squared e to the 10x, which is this one, x squared e to the 10x. So we have this. Okay, and this becomes the answer. Because the derivative of the x squared is 2x, and then you keep e to the power 10x constant, and we have x squared. The derivative of the e to the power 10x is e to the power 10x to differentiate 10x, which becomes the second square of x, and that is the answer. Okay, so that is exactly what we get. That is exactly what we get. That is exactly what we're getting. Any question, remark, comment? Nothing?
No.
All right, good. Thank you. Never mind. I always ask. I always ask to see. Okay, let f be a function defined by on which intervals is the function increasing? On which intervals is this particular function increasing? Right, I'm gonna, yeah, okay, remember that this is already a derivative. So we have been given f primed, which is 1 minus this. Let f be the function in this. On which intervals is f increasing? Right, so now the couple of things of this, you need to find the critical points where we equate these to 0, which means that you have this here, which means 1 minus x equals 1. And therefore, which means that if you're able to solve for x here, you'll be able to see therefore that 1 minus x is 1. So that in the end, then what you're able to get here is that x must be 0. X is 0. X is 0. So in the end, okay, when x is 0, right, when x is 0, you can be able to put it into this function. Okay, to the right of to the right hand side of 0 and to the left of 0. Let us deal with what happens to the right of 0. So you'd have, for example, when x is a 1. Okay, so 1 is a very important one. So when x becomes 2, for example, okay, between 0 and 1, what happens? Like at 1/2, this is 1 minus 1/2, which is 1/2. 1 divided by 1/2 is a 2. 1 minus 2, it's a minus 1. So you have a negative. Bigger than 1, like 5. 1 minus 5 is a negative. Giving us a plus here. Less than 0. Less than 0. Like -3. Put here, it becomes a plus. Okay, so that will be a plus. -3 is going to be a plus. Like -3 minus -3 is going to be like 4. So it's like 1 minus 1/4 is a plus. So you can see that it is increasing here, it is decreasing there, it is increasing there. So on which intervals is f increasing? So we are able to see that f is increasing whenever you have that x is an element of the interval minus infinity to 0, or you also have 1 to infinity, like this. Any question? Any remark? But this is exactly the answer, and this shows the intervals whenever f is increasing. And also, I mean, we have the interval whenever f is decreasing, and that will be between 0 and 1. But yeah, that's not what we want. Right. I will always ask if there's a question. These are like short. They're not long. Okay, they're like short, but we have a chance to like discuss. Because the x equal to 1 here that we've put here, remember we got only x equal to 0 after making the first derivative 0. But the x equal to 1 is something. What do you call it? X equal to 1 is something, we call it the critical value. We have a critical value. We have what we call a critical value. Right, we go on. We go on. Right, so we go on. Right. Vraag 5. Gegee dat f of theta is theta plus the sine of theta. Whenever theta is an element of the interval 0 to 2 pi, 0 to 2 pi, like this. So what value of venus of theta will f be concave down? Okay, now we need to find the first derivative and the second derivative. The first derivative is going to be exactly the first derivative of theta with respect to theta is a 1 cosine theta. And this here would be minus sine theta, and this is less than 0. This is actually less than 0. So we continue. We continue. We continue. Right. So I mean, whenever this derivative is actually the second derivative is less than 0, that would mean that sine theta is bigger than what? It's bigger than 0. Positive, the negative. So you sort of multiply both sides by negative, and then equality changes direction. The inequality changes direction. Right. So at this point, you need to investigate something and then say, well, just make this equal to 0 first. So you can first do like sine theta equals 0, and then after you made sine theta equals 0, then you're going to have parts where this is 0. So sine theta equals 0, it means theta is arcsine of 0, and arcsine of 0 is 0. Not only 0, but now the sine is 0 at 0 and pi. And then you also have 2 pi. Right, so you're able to see, therefore, that you want to find parts where but now we're interested in the parts where this actually becomes greater than 0. So you can look at the sine graph a little bit, or just you can look at the Argand diagram. Okay, you can look at, okay, you don't even need, because you have the cast diagram here. And because of the cast diagram, you can tick the quadrants where the sign by a cast diagram, it is positive sharp, but the sign is positive there. So you're able to see, therefore, that theta is positive between 0 and pi. Between 0 and pi. Between 0 and pi. Okay, yup. But now, obviously, we're looking at ways positive, so yeah, positive. So you'd have to remove the square brackets, please. So you have to then say it is 0 because it is 0 at 0 and that. So you'd have between 0 and pi. Between 0 and pi, then the theta becomes exactly a positive. Any question, any remark, any comments?
No.
Nothing. Okay, we're good. On. I'm going to give you some of the questions, like short. If I see a short question, I'm going to get your opinion first. Bepal. Vraag 6. Question 6. What do you think, please? Try it. Yeah, I'm just giving you like a minute. You'll forgive me because I like the shorts, and then we shall discuss it together. But yet, I'm trying to make sure you think, a little bit as we go along, because you're gonna sleep, and it's not right. It's not right. It's not right to sleep. It's not right to sleep. It's not right to sleep. Don't try to sleep. Right. Right. Good. Good. Right. Please let us know when you're done. And then we
Okay.
can see what to do. We can see what to do. Right. Please
I
just,
got the answer as 0.
oh, that's fine. We're gonna check together. I mean, I've not done the question myself before, but yeah, we're trying. Yeah, well done. Congratulations to you. I mean, 0 is the correct answer. Let's check together. Right. So obviously, do this particular question, there are a couple of things you need to take into account. And as far as this particular question is concerned, the minute you substitute the 0 here, you'd be able to see that the top becomes 0 and the bottom becomes 0, meaning you use local rule. And the limit as x tends to 0, the derivative of the x is 1, the derivative of the sine is cosine x divided by 2x. Right, so if you put 0 here, therefore it becomes exactly 0 out of 0 still. And you do the limit as x tends to 0, the bottom becomes exactly 2, the top becomes exactly, there's a minus, the derivative of the 1 is 0, the derivative of the cosine becomes minus sine x. And therefore, this becomes the limit as x tends to 0, which is exactly sine x over 2. Right, sine x over 2, which is the sine of 0 out of 2, which is 0. So indeed, yes, you're right that the answer is actually a 0 here. You're right that the answer is 0. Well done to you. Move to the next point. Okay. Let's look at this one. I'm going to give you this one as a brain teaser. And then we can discuss it together. Okay, if we give you like y equals ln x to the power x, and then we need to find dy dx, what do we do? What do we do here? What do we do here? What do we do here? So you try that one, you try that one. Yes, hello, Nose Mom, and how are you? Fine, thanks, Nose Mom. All is well. Thank you so much. Yes, yes, excited. Tomorrow is our meeting day. Okay. Okay, that's fine. That's perfect. That's perfect. She will just therefore just have to think of the time and let me know. That's okay. Yeah, 12 will be okay with me. Yeah, it's okay with me. All right, yeah, definitely right, because the exams are here already. Yes, physical, yeah. Okay, yes, program and whatnot. physically. Okay, that's fine. Yeah, yeah, it's a perfect arrangement. It's a good arrangement, I think. Yeah, thank you. Yeah, thank you so much for giving this young person a chance. You see, the exams are around the corner, and it is a perfect chance to learn and master the topics because, once again, the trials are starting in August. Yeah. So, you see, the timetable is out. I'll have to check again. But you see, I've posted on the group. Yeah, but no one has seen the timetable for the trials. I'm just gonna check again, but yeah, the trials in Gauteng are starting because see the trials are provincial exams. Each province has their own timetable. So yeah, but now I've shared it on the WhatsApp group. Never saw it, but I know that they're still thinking it's in August, but the dates are out. The timetable is out. You know. Yeah, definitely. Yeah, I'm just gonna share today afternoon the timetable again so that she can see it, but also you can take a look at it and just see the dates. And yeah, so that obviously when you think about everything, you can think because you see the trials, once again starting in August, they are very important because they provide a gauge, they provide an evaluation. Um, they set the standard, they indicate to the kids how ready they are for the finals. Yeah, so yeah, that's excellent. So what I'll do is I'm gonna share the timetable again because I shared it on the WhatsApp group. I know it was a while that I shared the timetable for the trials as much as the timetable for the finals is out. But yeah, for the trials that are coming next month in August, I will share it again. I'll send it to you on WhatsApp because I know that Neo is on our WhatsApp group. So yeah, I'm just going to share, the trial timetable. You take a look at it also so that because, I mean, the trials are very important so that you can look at how best, the dates, the planning part of it. I'm sure they will sort of help. Yeah. Yeah, for the fiscal lessons, most definitely. Yes. Yes. Yeah, the trial exam timetable, I'll just send to you so that you take a look and just know the dates as well. Yeah, so that you can know what is supposed to happen, when they need to write their paper one, because the kids forget. I mean, the kids forget because sometimes I mean, it happens with the matrics because it becomes a problem when the kids are not going to school. They're not going to school. Sometimes they sit at home and they read the timetable the wrong way. I mean, I've seen kids doing that. Somebody thinking you ask a kid and they tell you they're not writing today when there's an exam. I mean, I once saw a kid going to write their paper in the afternoon, thinking they're going to be writing in the afternoon at 2. By the time the kid was going there, everybody was going home. Then the kid was like, why is everybody going home? And then everybody was like, we're done. We wrote in the morning. The kid was like, aren't you writing at 2? So it happens. It happens. Yeah, definitely. So it becomes so terrible if it's the final paper. But yeah, because the final papers are only given once and the school can't do anything. Yeah. Yeah, the school can't do anything with the finals because if a kid misses the final, it becomes something of next year. It's unlike the prelims. The kid can miss the prelims, but the truth is prelims are written at school level, they're marked at school level. Even if a kid misses the prelim paper, the school should and must give the kid a chance to write the paper. I know that but it becomes so unfair because the paper is out and the kid would have seen the paper with friends. Is it fair for the other kids who wrote the paper for the first time, something like that. Yeah, but the trial paper kids the schools must give them because they can't, in principle, they can't allocate a 0 mark because it's because of extended opportunities and whatnot. All right, but yeah, that's fine, Noah's mom. Yeah, but thanks for the call. Right. Yeah, so yeah, 12 it's okay. So if Neo is okay with 12 tomorrow, yeah. Yeah, I understand. Yeah, but yeah, she must just think carefully of the right time. Yes, that's fine. She must just think carefully of the right time that is. Yes, please. Yeah, that's perfect. You must just think carefully of the right time for yourself because I'm very flexible. I'm very flexible. Yeah, yeah. In particular, online is much easier for me, so I'm flexible anytime. But yeah, she must just make sure that she chooses time that is the most convenient for her. All right. Yeah. So yeah, thanks a lot, Noah's mom. We'll keep in touch then. All the best. Okay. Okay. Thanks, Noah's mom, and goodbye. Thanks. Goodbye, Noah's mom. Goodbye. Thank you. Yes. Great. Thanks. All right. Thanks, Noah's mom. Right. So we're right back now. I'm so sorry that I was speaking to someone. And it's a parent. It's not, if it was a kid, I should have. Okay, you got the answer. What answer did you get? Hello, Atlahong.
1 over x ln x.
What? 1 over x ln x, like
Ln x.
this.
No.
Okay, 1 over
1.
x ln x, like this.
Yes.
Okay, because I'm just trying to. Are you sure? Okay, that's fine. So you're saying the x and the ln x are like in the denominator?
Yes.
Okay, that's fine. Yeah. Next. Okay. Is it only this?
Yes.
Okay, that's fine. That's fine. No offense. No offense. I'm not trying to judge. I'm not trying to cause harm to you. You can be like, hey, I don't like trying questions because the kids don't like trying questions. So to do this particular one, we need to do the following. So what we do is, because we have the power of x, when x is the power, we take the lead both sides. Right, so when x is a power, we take the lead both sides. And we have x, the lead of ln x. Okay, so, okay. And then now you find a derivative of this, which is 1 over y dy dx. Okay, the derivative of x is 1 times the ln x. And then now we have the x. The derivative of the ln is 1 over ln x times 1 over x. So that we have 1 over y dy dx, which is the ln of ln x plus the x cancels, giving us 1 over ln x. Okay. We continue. Right, so continue. Then it means at this point we have dy dx, which equals y, the ln of ln x, okay, plus 1 over ln x dy dx. Okay, then what is the y? Okay, so you have exactly this here. And you have the ln x plus 1 over ln x, like this. Okay, so that is the answer. Okay, take a look at this one and think about it. Take a look at this and think about it. That is the answer. Any question, any remark, anything to add, remove? Any suggestion on this?
No.
Nothing. No suggestion. Move to the next point. Right, so this one is called implicit. Implicit differentiation. With e to the power xy, which equals y squared out of x. What do you do here? I'm giving you a minute. You forgive me, it's not fair to you sometimes. I'm not fair. I just give you the question sometimes. I feel I'm not fair, but I give you a chance to try. I don't like giving questions to students. My feeling sometimes I need to do the right thing and not sometimes what I feel. Sometimes I feel like, okay, if I coach the player, I must take care of the player like an egg. Because this egg is going to crack and break. So I must take care of the egg. So I must not be like brutal to the egg. I must be kind and soft. So in the end, then I must make sure that I don't expose you to the harshest of problems. But simultaneously, I feel, okay, but I must give you a chance. And I'm giving you a chance. Please forgive me for giving you a chance. Okay. What do you think is the answer to this one? It's a bit long. Okay, I'm going to ask you part by part. Because it's long. I'm going to ask you, what is the derivative of e to the power xy? What do you think? The derivative of e to the power xy.
E to the power xy.
Your e to the power xy. Good. So it is e to the power xy, then you multiply by the derivative of the top. The derivative of the x becomes 1 times y dy dx. Okay, the derivative of the... Now you then say that you multiply, you take the denominator, you multiply by the derivative of the numerator. Y squared is y squared dy dx minus y squared times the derivative of the denominator, which is 1, divided by x squared like this. So this is what you get. So at this point, here we use what you call the quotient rule. Right, we use what you call the quotient rule. Right, we cross multiply here, the x squared goes that way, giving exactly x squared y, plus then we have x squared by x cubed. Which is actually the same as 2xy dy dx minus y squared. Okay, the dy dx becomes like something, common factor. So, okay. All right, so it's x cubed e to the xy 2xy. Okay, we have taken out the dy dx. All right, so yeah, you'd have this one, the 2xy, move it to the left. Minus this. Minus x squared e to the xy. So we have this. Subtract. So dy dx is minus this x squared y e to the xy divided by x cubed e to the xy minus 2xy. So that becomes the answer. Any question, remark? Anything to add?
No.
Nothing to add. Okay, pretty straightforward, right? Pretty straightforward. Pretty straightforward. Right, so we're good. We're good. Right. We're good. We're good. We're good. We're good. Right, so we continue. We continue. Right, so. Right, no question. So proceed to the next thing. Right, so if you use logarithmic differentiation to find the derivative of this, you need to take the log, which is ln y, the ln of the right, which is the sec of x plus 1 the sec of x plus 1 divided by 6 to the power x squared minus 1. So we have the following. Right, so if you use the ln, which is the log, so you have the ln of the top. Minus the ln of 6. Okay, so at least 6. Okay, so now you have the ln of y. 1/2 the ln of the sec, x plus 1. Okay, now then you spread this one. Okay, minus 4. The ln of x squared minus 1. dy dx. So it's 1/2. Right, so we continue. Okay. Right, so now we then say the following. Okay, so let's find the derivative of this. Okay, which is 1 over the sec of x plus 1. Derivative of the interior is 1. Okay, now derivative of the x is 1 by ln 6, because x is the only variable, ln 6 a constant. So over the derivative of this one is x squared minus 1, then the derivative of the x squared minus 1 becomes 2x. Meaning we have dy dx. All right, so we have 1 over x plus 1 ln 6 8x divided by x squared minus 1. Okay, so in the end, then we have sec of x plus 1, 6 to the power x squared minus 1. Okay, this is the y. And the inside becomes, you can write it as 1 over 2 the sec of x plus 1, the ln of 6, 8x, divided by x squared minus 1. Right, so we continue. We continue. Right, we continue. Right, okay. But now I want to mention something here. Because here it becomes 1 over the secant, but the derivative of the secant becomes sec 10 times 1. So this here is going to become exactly sec x plus 1, 10x plus 1. Okay, because it's 1 over, then derivative of the inside is sec x plus 1, then this cancels out. And in the end, then this is going to just be 1/2. Then you're going to have sec cancel sec, and you're going to have exactly a change here to this one. Okay, yeah. So yeah, I'm gonna have to change to this one. Okay, so this is gonna be 1/2 the 10 of x plus 1. 1/2 the 10 of x plus 1. So this is exactly what we get. This is exactly what we're getting. Exactly what we're getting. Right, so any question?
No.
No question. So now we have the following. All right, so y'all, we're good. We're good. Right, so okay, so yeah, take a look at that and see what you get. Right, so good. Right, so we're good. Okay. Awesome, 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 awesome. Awesome, 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 awesome. Right, so yeah, this is what we have. But now, please note that this is not a power. Write things properly. Right, so this is not a power. So this is minus ln 6 minus 8x divided by x squared minus 1. So this becomes exactly the answer to the question. This becomes exactly the answer to the question. Any idea, any input, anything?
No.
Nothing. Okay, yeah, but this would be the answer to the question. So think about this. Make sure you understand. Make sure you understand. We move on to the next point. Okay. Let me give you this one. This is the limit. As x approaches negative infinity. Right, so please, we have this. Right. So, okay, let me know please when you're done. Let me know when you're done. Okay. So yeah, we're good. We're good. It's so good. So good. So good. Right, please let us know when you're done.
Okay.
All right. So, yeah. Okay, so, yeah. Okay, we're good. How far?
Almost done.
All right. All right. Just giving you some brain teasers. Yeah, just forgive for the brain teasers. These brain teasers are just there to tell me, to give an indication on your state of preparation or readiness for this. Your state of preparation or readiness for this. You have the limit. Which is x squared e to the power x. Right. I'm sure getting close to the answer. So continue. Right. Please let us know when you're done.
Okay.
All right. Just practice. Practice makes perfect. There are like tons of questions here. Lots and lots of questions. Okay. Right. All right. All right. All right. All right. All right. Okay. Remember, just practicing. So yeah. There's no train smash here. It's not a witch hunt. It's not a witch hunt. It's not a witch hunt. Um, right.
I got the answer.
We continue. What else did you get?
Negative infinity.
Okay, that's fine. We're practicing. So now we continue, and then we then say, if we take the limit as x approaches negative infinity, so this one here, the x squared is going to be infinity and then 0. So which means therefore you have this. So now you need to therefore obviously look at this question, and what answer you get again?
Negative infinity.
Negative infinity. Okay, that's fine. We're taking a look and we're trying this particular question together. So now, as you look at this particular question, a couple of things you need to take into account. So it is, you can write this one as x squared divided by e to the minus x. In which case, as x approaches negative infinity, whatever you have here is you have infinity over the bottom itself. It's going to become what exactly? It's going to become infinity. Meaning, therefore, at this point, you're at liberty to use L'Hopital rule. As x approaches negative infinity, the derivative of x squared is 2x minus e to the minus x. The limit as x approaches negative infinity, which is 2x divided by minus e to the minus x. Okay, so at this point, if you look at these very carefully, if you substitute the minus infinity, it's going to be minus infinity. Then this one here is going to be minus infinity. Meaning you need to differentiate again and take the limit as x approaches negative infinity, which is 2 divided by e to the minus x. And therefore, what then are you able to achieve at the end of this? So you can be able to write this as the limit as x approaches negative infinity, which is 2 e to the power x. And therefore, it is 2 e to the power negative infinity, which is 2 divided by e to the power infinity. 2 to the e to the infinity is actually exactly infinity, and then we have a 0. So now this limit here becomes a 0. Where's a question on that one? Any question on this one?
No.
Is everything very clear?
Yeah.
All right. All right. So yeah, we move to the next point. We move to the next point. We move to the next point. Right, so question 3, use the closed interval method to find the extreme values. Find the extreme values of f of x divided by x squared plus x plus 1 on the interval. On the interval minus 2, 1. On the interval minus 2, 1. All right, so use the closed interval method. We need to find first, we need to note that f must be continuous, or we know that that is what it requires. So f is continuous on minus 2, 1. The critical numbers would be f primed. Okay, so you can write first f of x, which is this, but it can be written as x squared plus x plus 1 to the power negative 1. F primed would be negative x squared plus x plus 1 to the minus 2. Then the derivative of the inside is 2x plus 1. Right, so which means you have f primed, which is minus 2x plus 1 divided by x squared plus x plus 1. Can put some parentheses here. Okay, so now then you would have to then say the derivative is 0 here. And if you make this force this derivative to be 0, it means the numerator is going to be 0. And if the numerator is going to be 0, it means that x is going to be what? It's going to be minus 1/2. Right, so if x is minus 1/2, so we have actually a critical value there. So because we're using the closed interval method, and we are looking at the fact that we have a critical value that lies between this, you have minus 2, 1, and then you have an intermediate value, minus 1/2. So you go on and substitute into the function, and you have the following. Right, for example, if you have the f of minus 2, put in the place of x here, you have minus 2 squared giving us a 4 minus 2, which is a 2 plus 1, 3. And this gives us 1/3. F of 1 is going to be 1/3. Okay, yeah, let's do this. Well, a little bit in order. Which is minus 1/2. And if you do the minus 1/2 here, you would have 4/3. So if you do the 1, f of 1 is 1/3. All right, so in the end then, you have these particular values. So if you have these particular values, you actually are able to make the observation. And the observation is therefore that f has a global minimum. Right, so you then say f has a global minimum of 1/3. Because now you look at the values, right? Right, we continue. All right, we continue, and then you say f is a global minimum at of 1/3 at x equals minus 2 and at x equals 1. Is a global. Next, f has a, okay, yeah, it's right in intermediately. It's right here. Okay, so f would have a global minimum because now you're able to see that the 1/3 within this interval is sort of the global minimum. And then you would also note that f has a global maximum, which is the global max of 4/3 at x equals minus 1/2. Okay, so now you look at this, you take this is the closed interval because you need to use the closed interval method to find the extreme values of f of x. on the interval from -2 to 1. Right, between -2 and 1, then you're able to have the intermediate value, which is -1/2. And then we have f of -1/2, and f of -1/2 becomes exactly what? Right, f of -1/2 is 4/3. Why the -1/2? Because we got that x equals -1/2 is a critical value when we put the first derivative to 0. And then we get that f of -1/2 is 4/3. And then f of -2 would be like 1/3, and f of 1 would be 1/3. All right, so with these then, you're able to note that here is 1/3, 1/3, which are the extreme values at -2 and 1 of the closed interval. So f is the global minimum because this 1/3 is like 0.3, 0.3, but this one is 1.33 recurring. So in other words, the 0.3 recurring would be the global minimum, and this happens at x equal to -2 and also at x equal to 1, -2 and 1. F is the global max of what? F is the global max of 4/3. 4/3 at x equal to -1/2. At x equal to -1/2, the function has a global maximum there. There's a global maximum. A global maximum. A global max. Any question on the closed interval method? Any question
No.
on the closed interval method? No question. We move to the next point. Given that f at x is that one, use the first derivative to test. Use the first derivative test to determine the local extreme values of the function. Yeah? So now you'd have to say f of x is x e to the power minus. What is the derivative of this one? Atahan, what do you think?
Negative x e to the power negative x
X e to the
plus
power negative x plus.
plus e to the power x negative x.
E to the power negative x. Well done. Okay, and this is exactly what we're getting, but we can pull out a common factor. Right, so which means that therefore you're going to put these to 0, and this means that x is 1. Right, and obviously you'd have that x is 1 because you'd get that x is 1 for this factor, because e to the minus x is not 0. E to the minus x, not e to the minus infinity, but e to the minus x. So you have that e to the minus x is not 0. It's not 0. So or the only factor that is 0 is the 1 minus x. So you have the 1 here. Okay, bigger than 1 you put here in the place of the derivative. So this would be like f primed that you actually would be substituting into. Okay, now bigger than 1 is like 2. 1 minus 2 is minus. Less than 1, like half. 1 minus half is plus. F has a local max. Has a local maximum. Right, because here it is increasing, then there it's decreasing. So it means that because it's increasing, then it's decreasing, positive to negative, then it means that there's a local maximum at the point where x is 1. But when x is 1, then y is what? Right, so when you actually are able to put x to be 1, then you need to be able to get the y value. So you put into the function there, which means that if f of x is x into the power x, f of 1 is this. Okay, yeah, but yeah, 1 times that. So, which means that Okay, so this is going to be exactly this. It's going to be exactly that. Any question, any remark, any input, anything to add, remove, or whatever?
No.
Nothing.
Mm.
Okay, we're done with Flachvier. Okay, this one is a completion thing. Sometimes I give you a chance, sometimes I don't, because yeah, it's a game. We are like exchanging ideas, giving you something, and then I tell you something, then you also, yeah, it's just a part of the thing. Complete the following definition. Complete the following definition. Right. The number C is a critical number of F if what? The number C is a critical number of F if what? Now this is like the definition of a critical number. What is a critical number? So the number C is a critical number of F if what happens? Okay, the couple of things you might forget this one. But the critical number when C is an element of the domain of F, so C must be in the domain of F, such that C must be in the domain of F, such that F prime of C equals 0, or F prime of C does not exist. It does not exist. Okay, so the number C is the critical number of F if C is an element of the domain of F such that F prime of C is 0, or F prime of C does not exist. Any question on this completion?
No.
No question. We move to the next point. Determine the critical numbers of f of x. Okay, what are the critical numbers of f of x? Okay, so let's do this one. What is f primed? Derivative of x squared is what? Is 2x. Derivative of the top is 1. Then we have this one squared. So which is 2x squared minus 2x minus x squared. So you have x squared minus 2x divided by x minus 1 squared. You pull out x and you have x minus 2 divided by x minus 1 all squared. Right, so you're going to proceed and say, if this is the case, if you have f prime of x 0, and we have the following. Right, we have the following. Right, so f prime becomes 0, which means that if this is 0, this would imply that x is 0 or x is 2, which means f primed of x does not exist right, does not exist when x is 1. Because we can see that the derivative does not exist when x is 1, but 1 is not in the domain of f. So the critical numbers are 0, c equals 0 together with c equals 2. As c equals 0, c equals 2. Right, so we then have the following. We then have the following. Right, so we're getting these then in the end. Any question on this one? Okay, because we see that f prime of x does not exist when x is 1, because when x is 1, there's division by 0. But 1 is actually not an element of the domain of f. So the critical numbers are 0 and 2. The critical numbers are 0 and 2. Any suggestion on these? Any comment, remark, anything to add, remove?
What is the domain of the function?
Okay, that's a good question. What would the domain of the function be? So the domain of the function f would be, right, so the domain of the function will be the set of x values for which the function itself is defined. And at this point, it would be, the domain of f would be all real numbers without the number 1. Or simultaneously, I mean, you could say it is all real numbers without 1. So this will be obviously the domain of the function. And therefore, I mean, looking at the domain, you're able to see that 1 is not, because it's removed from the set of real numbers. So in other words, 1 is not in the domain. That is why we're saying f prime does not exist when x is 1. We note that f prime does not exist when x is 1. So f prime, the derivative, does not exist. But we know that 1 is not even in the domain, because the domain is without 1. 1 is removed from the real numbers. And therefore, so the critical numbers therefore become 0 and 2. We could say, somebody would come and therefore say, okay, is 1 a critical number? Well, we would note that therefore first, the f prime does not exist. F prime does not exist when x is 1. But we note, hang on, but this function is such that 1 is not in the domain of the function f. So the critical numbers are c equals 0, c equals 2. So this is what we have. This is what we have. So this is what we have. All right. Any question?
No.
Next, move to the next point. We move to the next point. Yeah, I think that this will be some good amounts. Maybe we can do one question. Let's do one question. Let's see, we do one question. I think that, yeah, these will be some good points to stop. And we have discussed for on average the amount of time. And so it is some good time for us to stop. Maybe I can give one question. There's too many questions here. Can give just one little question as a small little quiz. A little quiz. Right, a little quiz. A little quiz. A little quiz. Right, a little quiz. Let's see if I can find something that I can give extra. Okay, something easy. Right, so this one here, let me see. Um, all right. Okay, let's see if I can give something. This one. Please try this one. Okay, I know it's so small. Okay, if you give you the limit of 1 plus kx, 1 over x, k bigger than 0. Okay, please try this one. And let us know when you're done.
Okay.
All right. Right, please let us know when you're done. Let us know when you're done. Right. Let us know when you're done.
Okay.
Right. Right. We continue. Right. 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 We continue. Right. We continue. We continue. Right. 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 How far?
Almost done.
All right. Continue. We continue. We continue. We continue. Right. We continue. We continue.
I got the answer as infinity.
You got the answer as infinity. Let us check if this is the case. Right. So there are a couple of things we need to do here. So we continue. Then we have the limit as x approaches 0 of 1 plus kx to the power 1 over x. And this becomes, okay, if you take the limit, substitute the place of x, you have 1 raised to the power 1 divided by 0. It's a plus or minus infinity, that. Okay, so in the end, then what you're able to see then is that we have the limit as x approaches 0, which is e to the ln of 1 plus kx to the power 1 over x, which is the limit as x approaches 0, e to the power the ln of 1 plus kx divided by x. Right, so we continue then to investigate this one here. So we further subdivide the board like this. Okay, so as x tends towards to 0, then the bottom becomes 0. But in the place of x, you put 0 here. It's going to be k by 0, which is exactly 0. So it's ln 1, which is 0 out of 0. So yeah. So this means whatever you have here is you have the limit as x approaches 0. And then we have e, which is 1 there. 1 out over 1 plus kx, which is exactly k. Which now as k approaches 0, which is k, like that. So if you look at this particular question very carefully, you're able to then see that the limit here becomes exactly k. And so if the limit then becomes exactly k, it is precisely what we have here. So any question on this one?
No.
No question. Right, so that is by and large how these questions obviously it had to be done. But you know that this is the answer together with K positive. K positive. Right, so yeah, that is the answer. But we thank you for joining us. It was also having this discussion. We shall send you the video in a couple of minutes. Thanks a lot, dear, and have yourself a good afternoon. Right, we shall discuss our next meeting.
Okay, thank you.
Thanks. Bye.
Bye bye.